taking out our derivatives. And I know we didn't get to that one last time. In all honesty, most of it, if not all of it, is something that you could handle. We'll show you something that might be slightly different, or a different way of looking at them. Oh, actually, I don't know which of these is the most recent one. And sign in. Oh, I don't think I even allowed you to. Hang on. Yeah. So sign in as well. We're going to give you some time. Where did we leave off? Just find where those questions were. So I copied them all in. I don't want to lose what we did. It was after day 6. So we did our rules day 6. No. Okay, so I didn't put it in that one. Notes. Where'd all those questions go? Oh, here we go. All right, so I guess first off, it's up to you how we want to go through and do these questions. Were there specific ones from that group that you wanted to see gone over? Let's start off, I guess, with that. Were there specific questions on that white sheet that you wanted to see gone over? If not, we're just going to start ripping into them, and I'm assuming then that you know how to go through and do all of it. All right, and we'll get started. I'd start off, I guess, at the beginning. We'll ease our way in. And I think I did mine from easiest, or sorry, from hardest to easiest. If we were going through and listing this out, let's take a look maybe at number 5 to start with. And at number 5, your job is to find your derivative. There's a couple ways that you could go through and do this. I'm actually going to make this a little bit easier on myself. This is about seeing alternate forms sometimes. When you see this, it may look as though when you do it out, what derivative rule do you think this probably would use? Yeah, you're thinking it's probably going to use the quotient rule, but watch how this gets manipulated so you now can avoid using the quotient rule. And you can use your shortcuts if you can remember how to get things into the right form. You guys are insanely good at taking derivatives of polynomials and using the power rule, which means your coefficient times your exponent and then lower the power by 1. You're good at that. Look at that denominator. Let's start off with what we have in your denominator, because you're going to see if we don't do this outright, you're going to miss some simplifications here. Hey, what would you get if you took the denominator and cubed it to start? Close. No, your power was right. You didn't cube the 3 also. What's 3 cubed? 27. So now we're to here. Are there any reductions that I can do? Are there? Yes or no? Yeah, it looks like right now, what can reduce out, Joey today, Sabrina, what can reduce out that's up there? So what's 9 over 27 going to reduce to? Now, I'm going to write it out this way. I got 1/3, but now, and see how your x was in the denominator? I'm going to make it 1/3 times x to the -6th power. All I did was say, hey, the denominator is where the x was found, so I'm going to write it out as a regular old term with a coefficient and an exponent. Those mean the same thing. So we have questions on that. If you can do that, now you can take the derivative using the power rule. And looking at what's there, Alexa, how would you take your power rule derivative here? So what's -6 times -1/3 going to give you? Yeah. Wait a minute. Is that a half? It should be. Yep. So this would work out to be 2. And now, that would be x to what power? Remember, you subtract 1. Subtract 1. So our derivative, or y prime, would equal 2x to the -7, or how else could you give out that answer? Yeah. Y prime, or your derivative, could also be 2 over x to the 7th. Do we have questions on that one? Getting it in that form is going to be so helpful to you. Oh, I'm going to go backwards. Take a look at question number 7. You may think that that's a product rule, or sorry, a quotient rule. It really, in all honesty, shouldn't be a quotient rule. What are you doing to each of those terms in number 7? You've got a trinomial in the numerator. What's happening to each of our terms? They're getting divided by 3, so isn't y equal to, now instead of this being a quotient, this is really 4/3 x squared minus 5/3 x plus 2. How would you go and take your derivative there? What would you go through in half, Teresa? Yep. And what's the derivative of 2? 0. Now, 9 was given to you because you're probably not going to see something in 9. Or, even worse, think that there's an immediate reduction. There's not an immediate reduction. When you see x cubed plus 8, though, what should you be thinking about? It's factorable. It's a sum of perfect cubes. So I'm going to rewrite out my numerator. This is not accidental. Y is equal to, your denominator is still an x plus 2. Your numerator is a binomial and a trinomial. What are your signs going across when you do a sum of cubes? Who remembers that? One person. What do you want to say? Yeah, it's going to be plus, minus, plus. So my binomial is x plus 2, cube root of the left, which is an x. Root of the right, which is a 2. Now over here you'd have x squared. You've got a 2x here and a 4 here. Do we have questions on what we did to factor that down? What was the whole point of doing the factoring then? Mirka, what's the benefit for us? The x minus 2 is reduced, so y is really equal to x squared minus 2x plus 4, which means y prime, its derivative function, Christina, would be what? Yes. Oh, I'm not? Okay. Oh, he might be. All right. My link, we'll see. I might have screwed something up. Let's see. I'm not screen sharing. Share. My main screen. All right. Maybe now it works. Okay. Take a look. Now, 14, I don't like that form. So rewrite those out with exponents. What would 14 be rewritten out with powers? We got 1, 2 of us, 3. What do you want to say? I love that you get so afraid of fractions. Somebody could be running around, screaming at them that a total nutjob could be in the hall. You'd want to take that person to prom or ball before you'd want to deal with these fractions. That's how afraid you are. If you go through, you can take 1/3, subtract 1, and not need a calculator. How much is 1/3 minus 1 going to give you? 1/3 minus 1. You have 1/3 of a pizza. Should be negative 2/3. So this in front now, 1/3 times 1 is 1/3. X to the negative 2/3 minus, this would be 2/3 times 1. What's 2/3 minus 1? Negative 1/3. If you needed to reformat your answers, you could also say y prime equals 1/3x to the 2/3 minus 2/3x to the 1/3, or any form of that. This one in 15, I mean, I'll tell you this. I hate going through and using the product rule or the quotient rule if I don't need to. Could you expand out that numerator and then divide each of the terms by an x? And the answer is, I think you can. I think you can. I think that's probably the easiest way. You could do quotient rule on it, but you'd have to blow it up. What else was one? Now, when we get over here, these are the questions that are closer to what you'll see on the AP. Did he get that to come through? Am I working now? Yes. Thanks. Now from here, you've got to do two things on here. What's the first derivative rule that 21 would require you to apply? What's the first derivative rule you would have to do in 21? It's not quotient. You see the product first. The product is the bigger operation, which means you've got to do 1d2 plus 2d1. It doesn't matter which one goes first. So I'd start off and say, I've got to do 2d1. So 2 is 3x minus 2 times the derivative of this. What's that? Watch what happens when we do our derivative of that second piece. You've got to do the derivative of that, which requires you to use the quotient rule. So now, if you've got x minus 3 over x plus 4, quotient rule tells you how to proceed forward. What would you have to do just to take your quotient rule here? Remember the acronym for quotient rule? Did you write it down in your folder book? Have that out, by the way, guys. If you don't, because I want you. If you don't know it, that's fine. We're still sort of in those beginning phases, but I need you to be able to find it if you don't. So, and if you need the acronym to remember it out, that's great. I really don't care. It's all about what it would take for you. Do you see that acronym? So what's the low in this going to be? What term is the low? What's your denominator? Okay, so you took low times what? Read it going across. Said it was low. It was low d high, right? So that means the derivative, when you say low d high, that means the lower term times the derivative of the higher term. So what's the derivative of your numerator, or your higher term? 1. So you got low d high, and then what's after that? So minus, what's the high? What's your d low? And what goes in the denominator? So what's low squared going to be? X plus 4 squared. That's the tough part. Now, sorry, that should be X minus. Now, once we got to here, you did we did 2 d1. Now you've got to do plus 1 d2. Plus 1 is x minus 3 and x plus 4. What's d2 going to go through and be? Angel? What's left to take the derivative according to product rule? Well, we did, it doesn't matter which order you go, it's the one part times the derivative of the other. So this is 2 d1, so I need 3. That's all right. Now, once we get to here, take a look up at your numerator. Look at what you can simplify down. Now, by the way, technically, is this the derivative? Yeah, let's see if we can tidy it up. I don't even know if you can. I'd say y prime, this would be 3x minus 2 over 1 times, over here you've got what, x plus 4 and x minus 3. That leaves you with what, 1 over x plus 4 squared minus 3 times x minus 3 over x plus 4. I mean, could you go through and find a common denominator and keep going if you wanted to? But is that the derivative, yes or no? Yeah. Okay, so we need you to get to that point if you're not there. Other things we need to go through and recall. What does it mean if I went through and had a derivative value of, let's say at 2.5, my derivative was 5. And my derivative value at 3 is 0. And my derivative at 3.5 is negative 6. If the function is continuous, and that's a big if the function is continuous, what is happening at 3? If your function's continuous, what have you established happens when the x value is 3 of the graph of x? What would you say and why? Why would you say that the 0.30 is a turning point or a max? Why would you say that? Candidate for it. It went from increasing slope or positive slope to negative slope. So what did you establish happens there? A maximum. Yeah, it was going up and now it's going down. What if we got something like this? If this happens, what does it mean is happening at 3, 0 then? What you're thinking, yeah, Tom? Play it out. The slope went from 5 to 0 to 6. What's there? Yeah, it's a cubic graph. Is that a max or a min? No, why isn't that a max or a min this time? What'd you say? Yeah, did the derivative become negative at any point? No, did the graph ever turn negative? So that's when, and who was it that answered the A part? That you? The reason that I went back and corrected that one little piece where you're saying it went from, it changed or something, you've got to remember, just because there's a derivative of 0 does not mean there's a max min there. You just showed me. Is it possible for the derivative to equal 0 and you not to get a turning point? Yeah. Think about it. Was it you that said the cubic graph? And if you go through and graph out the cube, that's what you go through and get. Now, for our work today, and what you're going to be working on in here now, you've got this packet in front of you. Read what's there, and I'll even tell you this. Get with your 4s. You've got enough. Can we have you slide up here to finish out this group? We've got 4 here, 4 here, 4. Oh, wait a minute. Excuse me. There's 5. Let's add this. And you guys just supervise the 5. Is that okay when you play nicely with each other? No stabbing, right? No knives? Promise? Okay. You can say you want it, can you get them Skyped in? I can give you, the only problem is when I put them on that other computer, actually I think I might have it right. That says if I do it first on the tablet it would work. Let me see. Tommy, if you can hear me, I'm going to drop you for just a second. It's not personal. Get rid of this. So, all right, so, oh wait, I think I have to close this. No, I. Go through, get started right now on question 1. If you got stuck on 1, you can go on. 3, 8, 2. Ah. 7, 3. Yes. Cancel. Oh, wait, I think I needed this link. Join the meeting. 3, 2, 8. Go back, look at what's there, take advantage of all of the stuff that's given to you. Saying, I don't know, doesn't work. Discuss with your group if you need it. All right, so I think this works. Tommy, did you get that packet I sent over? Hang on, now I can hear you. Did you get that packet? Okay, so here we're going to have you work with Joey's group. I'm going to try to get it so the other screen will show up also. But that's what we're going to go through and work on, getting that first question done, all right? Yeah. It's like a baby. We're going to come back together in a couple minutes to start going over them, but get as much as you can done now. Okay, join with computer audio. Oh, look at Joey, you're famous. Look at, he's there. All right, so get going, guys. We found a way to get him so he can participate. The problem is, I think there might be a mistake. You have to that pad needs to log in for something. I'm just trying to. We're going to come back together in a couple minutes, but give those at least one. Give it your best effort to start. Use whatever resources you have. Give you guys another minute or so. How did you define speed? The absolute value of velocity, right? Speed is velocity. Was that MIT, right? Yeah. We talked about no. Get real. Let's take a look, please, now. Let's take a look together at what's going on here. I saw someone do this in here this year. Loved how this came out. Look at what's there. It says the graph shows the position function. So, if this is the position function, what does up here mean? What does it mean if you're up here? The position is positive or what? If the position is positive, you are on which side of the axis? Or sorry, which side of the origin? To the right of it. This means position is negative. Can you do me a favor, Joey? Can you turn the volume down on that thing? I think that's what Matt said was the issue. And now, if you're at 0, that means the graph is actually on the origin. You've got a particle moving left or right. So if it's on here, that means it's at the origin. When is the particle moving to the left? Now, you've got to figure out the moving. That means you look at the slope. John Paul, when is it moving to the left? Yeah, I'd say from 5 to 7, it's moving over to the left. That's an interval. I always use paren for my intervals. Teresa, when is it moving to the right?
0 is less than 2.
So from 0 to 1, and where else? 3 to 4, that's fine. When is a particle going to be stopped or standing still, Caleb? What do you want to say? Perfect. 1 to 3, and then from 4 to 5. Take a look now at the next piece. Graph the velocity and the speed. what is the velocity? Let's start off with that. What's your velocity? Yeah. Yeah, it's the derivative of your S of t function or your position graph. So looking at what's there, I go in and plot this out. What I guess is one of the slopes you plot, Angel, from where to where? You get to. Well, let's do, I guess, your first piece here. What's that slope going to be? From, yeah. And I put a, oh, I've got to remember, I think that it's a closed dot to start, but maybe then an open one here. And it gives you open circle there. Now, what else can I go through and plot? Lily, what else is going to be on your velocity graph? From 1, and I think it's open circles on those also. 1 to 3. The only ones I think get it are the end boundaries. Marissa, what else can you go through and give us? Oh, they're all open circles, sorry. Because when you're going through, there's a corner there. It's not a smooth curve, so it's not differentiable there, or the derivative doesn't exist. Mm-hmm. Yeah, the derivative value or the velocity is 4. Next one up from 4 to 5. What is that? A 0? Oh no. It's from 3 to 4. I carried it too far. And then from 4 to 5, it's what, back to 0? And then we are at negative 2 then, from 5 to 7. Now, that's what your velocity graph looks like. How is your speed graph going to be different than the velocity graph, or how do you get your speed graph? What's that? That would be acceleration. Speed is the absolute value of velocity, because speed gives you just how fast it's going, not direction. So the graph would look literally identical except for one piece. And we had somebody figure it out before. You're going through, recognize that that piece that was negative, the only part that's negative, is now going to be positive, and I think it's at 2, right? Something that looks like that. Do we have questions there? When is the particle moving the fastest? From when to when? Mark, what would you go through and say? Yeah. Let's say from 3 out to 4. Questions on that one? Slide over. Oh, next page. Now, I like this when someone else did it. Let's try it again. You're given, in this case, the graph of velocity. What does it mean if the output is in quad 1? What is that telling you? When the graph is above the x-axis and you're graphing out velocity, what does that mean? So I would go through and say, you're correct. And you gave a very technical explanation. Say that again. Now, that's the slope of the position function. So if it's up top there, what other adjective could you use to describe what's happening between 0 and 1 or from 4 to 5? Or sorry, 4 to 6. The function itself, f, is increasing. Meaning f is going up. What's happening if the f prime or velocity value is negative? Well, we know then that the function, actually, what an idiot. See how I labeled it f? What a dummy. Please don't throw it. S, your position function is increasing. Well, and actually I don't even want to say increasing. Because technically it's not increasing. What is it doing? The particle function is only going left and right. Yeah, it means it's moving right. I made that amendment because we weren't wrong in saying it's increasing, but it is wrong because of the constraints of the question. So we know S is moving right. This means S is moving left because your derivative is negative. You could say that too. S prime is less than 0. This would be S prime is greater than 0. And by the way, what does it mean if S equals 0? So I guess we'd say the particle is not moving. Okay. When does the particle go through and reverse direction? So take a look at what's there to start with. Christina, what would you go through and say? Reverse direction or change direction. No, that's when your velocity changes direction. Remember, we listed out on the right-hand side. If it's up top, it's moving to the right. If it's down low, it's moving to the left. So when is that transition happening? When is it changing position? No. When is it going from right to left or left to right? This is the motion value. So when is it going from positive to negative or negative to positive? At 1. And what value would that be? What would we estimate? We can say for sure t equals 1. And if I'm going to estimate maybe 4.1 for the next one, 4.2. T equals 1 and t approximates 4.1. Because as you're graphing that out, you're giving out what the graph is doing. You're trying to find out when it's reversing direction. You need to find when the graph is having a derivative that goes from right to left or positive to negative. When is the particle moving at a constant speed? So take a look. From where to where would this particle be moving at a constant speed? Joey, what would you say? Yeah, I'd say from 5 to 6. When is the particle going through and moving at its greatest speed? So take a look at what's there. When is this particle going to go through and move at its greatest speed? We got 1, 2 of us. When is it at its greatest speed and why? You're given velocity. When would this be at its greatest speed? Colin, what do you think? What'd you say? Not 0 and 5. He's wrong, but it's very easy to see why you would say that. That's a very logical assumption. It's not correct for one little bit of nuance within the question. What would we want to say, Kim? Why? Not x equals 3. T equals 3. Why?
The x value of the e value in t equals 3 is going to be greater than 25%.
Look at what's there. The speed is -3, but the speed at time 3 is it 3? Yeah, it's 3. The negative part of that gives you what? The direction. The direction on it is negative. So if the velocity is -3, that means it's going 3 whatevers units, but in this case to the left. So you could go through and graph out the acceleration. What is the acceleration? How would you go through and define acceleration? The acceleration function equals v prime, or you could also view it as second derivative of position. Remember we said before going down, position, velocity, and acceleration. So position's derivative gives you velocity, velocity's derivative gives you acceleration. Take a look now at this. This is one I think we can get. Particles moving along a vertical axis, so its position is given by that. And just so we're clear, when we're talking about vertical axis, what does that mean? What did you say? Thank you, up and down. So you have an axis here that's vertical, or upsy downsy, and then we've got a particle on here. All right. So here's our particle. Now, as the particle moves, the particle is only going to move up or down. That's it. That's it. The particle is either doing this, or that. It stops. Now, its position at any time is given by that function. Find the displacement during the first 6 seconds. What does displacement mean? Yeah, how far you are away from your starting point, the displacement. Now, do I know where I start? Do I? Yeah. And can I figure out where I am at 6 seconds? Yeah. So, if only there was some gigantic piece of passbook that I could go through and figure out what those values were. That's you'll never be able to know. Right, look at everyone should have Peter's attitude right now. I look back there and Peter just goes, hey, what are you gonna do? Can you imagine how little stress Peter's gonna have like the rest of your day? Throw you out of this house, eh? What are you gonna do? What are you gonna do? You sound oh my God. Yeah. Now, I will show you this, by the way. You need to find the change in position. So I'm actually going to go through, before I list this out, go over to your calculators, please. Let's see how many of us. So go in right now, type in define. We're going to make our lives a heck of a lot easier right now. And this is us getting ready to go beyond and be prepared for later on stuff. Go in right now, get yourself, new document. Go in and define S of t. And type in what S of t is. Type in define, space, and then we're going to do S of t equals, and then put in what that is. So tell me what S of t is, equals, and then type in exactly what it looks like. It's the same, looks like it's on your paper. So go in, type whatever that is. 1/3 and some change, or 1/6. Keep going. Okay? Now, we need to evaluate this out at what values to find the displacement. 0 and 6, so type in S of 0. So S paren 0. Use your S button down below. Notice now it should be bold. So S parentheses 0. Hit enter. That's the position at 0, negative 11. So it's below the axis then. Now evaluate it out at what value? 6. So do S of 6. So now, how can I figure out my displacement? Well, I would take S of 6 minus S of 1. Now, just so you're clear, I know that this very well may blow your mind. You can do this all at once, so type in S paren 6 minus S paren 1 and hit enter. Or 0, excuse me, S 6 and 0, yes. Sorry. And it's going to give you that all at once. So hands up, please, when you can tell me what that difference works out to be. What you got? 108? Now, how can you go through and find out what your average velocity is over that time? How do you get velocity? Yeah? Change in distance over change in time, or d. Change in distance over change in time. So in this case, it would be d dt. So as you're doing this out, your change in distance, how much distance did you change, or how much displacement did you experience? How much displacement did you experience? 108 over, what was the change in time? 6. Now, here's how you could write that out, just so we're clear. I don't want you to lose the derivative as a rate of change. I write out s of 6 minus s of 0. That's the change in y over 6 minus 0. That looks like a rate of change. I know you could go immediately into 108 over 6, but actually, just so you're clear, you can type this in exactly as it looks. Go over to your calc and do that out all at once. Do control division. And in your numerator, do s of 6 minus s of 0. Nope, clear that out, delete what's there, because we're going to do it all in one, and you're going to format it to make it look nice. Control division to start. Now do s of 6, close it, minus s of 0. Fabulous. Over, what would your denominator be? 6 minus 0. And enter. Did that work out to give us the same thing we had before? Does it take away steps for you? Yes. And by the way, what did this work out to be? 18? Now, what I'm going to tell you tonight is this. I think we're clear, just so you're clear if you're not. I can even, I think, send it out to you. 4 at the bottom is all boxed off, right? You don't even have anything. Go to page 4 on there. There's nothing on there, correct? Okay, there should be one, but the bottom is, okay. Your job, get that guy done. That's what your homework for tonight is. The rest of those questions, okay? I know that there's a couple within each one, but it's like, hey, based off the same graph over and over again, interpret it. Okay? I'll send you out answers, maybe to one of the pages, not the whole thing, but to one of the pages. Look, we're throwing things. We're so upset. We are outraged. Can we please get first people on their stars, everybody else get behind them?
Oh, yeah.